So the idea here is we are now going to get away from those boring problems, the ones where it was like Sally and Mark are selling cheesecakes, and then it felt like those problems. After a half a dozen of them, they had to just start feeling like I'm doing the exact same problem again and again. So now we're going to start seeing some worksheets, some problems they really require us to read carefully. And some situations are simple, some are not. And so you'll kind of see that throughout this worksheet that the equations sometimes can be very simple to write. But as we head down the worksheet here, um, they get a little bit harder. So let's get to it. We're still doing the same four-step process. And what is step one?
Find the, I don't know what to say. Find the thing.
Identify variable.
Identify, declare your variables. Tell the world what variables you're going to use and declare them, define them, bless you. And I will tell you this, a personal trick that I use is in a really generic problem like number one, I go into this assuming that one of the numbers is going to be larger than the other. So just to kind of give them a name, to give them sort of to have a face to put with the name, I like to declare them as L and S. And so that's my thing. I like to say let L equal the larger number. Okay. And logically, then I'm going to let S equal the smaller number. I don't know honestly that I've ever seen a problem like this where they turn out to be the same. Bless you. And logically, I mean, you would understand already that they seriously could not be the same because the second sentence tells me that they're 15 away from each other. So it's a good way to head in and just say if no one's going to boss me around. Let's look at problem two real quick. Take a look down at number two. I've already named those for you as the first number and the second number. So that's what we're going to call those. But when no one names them for me, a good way to give them an identity is to call them large, small. Okay? So having said that, that is step one. Step one is in the books. Let's write equations now. This whole next 2 weeks of our time together is all about step two. I want you to understand that before we do this. Like if you say, I'm really good at everything, it's just taking the words and writing the equations. Then if that's the case, then you're lost, completely lost. So our focus is not steps one, three, and four. Our focus is step two. Can I read sentences and write math problems from them? So let's begin. Do you know this word?
It's like the equals the amount, the equal sign on the other side.
So is the sum of 6 times 7 is 42 the sum of 6 and 7? It's the answer to an addition. You're the first one to say that. Thank you. So whenever I see the word sum, it's not just the answer to an equals, it's the answer to an addition problem. So like the sum of 6 and 7 is 13. The sum of -2 and 8 equals 6. Sum means add them together. So could you write me an equation using that fact and the letters L and S and some math symbols? Go ahead. The sum of the numbers is 101. What does that mean?
Two numbers when you're adding them.
Write me an equation. There we are. Now we're off and running. This right here literally says that the sum of those two numbers is 101. Putting L plus S covers the sum. That's what it means, right? Good job. Way to get us off and running there. The next math word I need to make sure that you're up to speed on is difference. Difference is the answer to a subtraction problem. So like the difference of 4 and 7 is -3. The difference of 7 and 4 is +3, so on and so forth. Correct. So we're going to say that L minus S equals 15. Addition, you have some freedoms. You could write them forwards, backwards, like L plus S, S plus L, nobody cares. Do bear in mind that with subtraction, if you put it backwards, it will be wrong, right? Addition is free for all, free form. Subtraction, you got to be real tight. So make sure you do larger minus smaller, L minus S. Any questions on step two? Then it's time to do step three. And what you're going to find is substitution will be back here in a little bit, but I think that this problem is pretty elimination-y, don't you? I mean, look at it. I don't even have to multiply by anything. I can just draw my line and go. Who is nicely going to just step out of the way.
Yes.
S's are like gone. Just add us together. We're done. So if we just add straight down the line, how many L's do we get? Cross out your S's. And what's 101 plus 15? 116.
I may not get, oh, I see.
Okay. And then how do we solve that? Divide by 2, giving us L equals half of 116, which is 58. Agree. But we're not done, right? Like all this LS stuff, all this algebra, no one asked us to do that, right? Well, I mean, your teacher did, but like the problem is just tell me what the numbers are. We know one of the numbers. How are we going to find the other one? Put it back in. I personally would put it probably right there. But if you like the bottom one, use the bottom one for real, like whatever, as long as you and I get to the same place, which this top equation now says that 58 plus some number S, I don't know what he is yet, equals 101. And then how do we solve that? Which gives us S equals none. Like step 3 is over. Out. In step 4, can you thank you. In step 4, we have to actually now pay attention and answer the question. Sometimes the question's going to be generic. What are the numbers? Sometimes, like you'll see in question 4, the questions are going to be more specific. And so just pay attention. When you come and you emerge from your math cave, make sure you answer the right question. But this question is just simple. So I would just write a very short sentence and say, the numbers are 43 and 58. Done. I don't need a comma in this because I'm only saying one thing. Now, if you wanted to be a little bit more delicate with your answer, you could say the larger number is 58, comma, and the smaller number is 43. But all someone asked me for is this. What are the numbers? So I just return a simple sentence for a simple question. Got it? You don't need a comma if you don't have a pause. And I didn't sense any pauses in that sentence. Good there? All right, 1 down, 3 to go. Let's head on to problem 2. And what do you think would be good variables to use here? Why do you say that, Dave? Yeah, the numbers have been named already by whoever wrote this question, which, spoiler alert, was me. So I want this one to be F because it's the first number, and I think we should call this one S because it's the second number. So let's go ahead and declare those. Let's let F equal the first number. And if you want to use the pound sign to replace the word number, that's fine. And then let's let S equal the second number. All right, so the equations will start to get a little bit more complex as we go through the next half hour here. So first equation, I'm going to teach you something called, I'm not your English teacher, I get that. But I want to really implore you guys to use something called chunk reading. And like if I were teaching my son at home how to read, I would teach him how to read in chunks. Sometimes it's best not to read a whole sentence. Sometimes it's best just to say like the bird is, and you talk about that, right? Flying across the sky. Like when we read math questions, it's the same thing. We want to divvy it up into small, manageable pieces. You won't always have to do this. There will come a day soon where chunk reading is something where you're like, you almost like quote unquote graduate from it. But this is the first chunk that I want you to look at. And I'm going to put it in a box. And I am being massively deliberate with that box. I need you to understand that the 7 is not in the box. This has been a struggle all day. You're my third shot at this, so let's give it a go. If I asked you just to write me no words, just math symbols, How could I replace the second number is? What would I write?
S equals.
Thank you. That's the quickest one today. You can replace all 6 of those words by just writing S equals. That literally means the second of 2 numbers is. The next chunk that I want you to read is this. What does that mean? You both were talking at the same time. What?
Multiply by 7.
Nope. Add 7 is correct. Notice that I am not going to write 7 plus. I'm going to leave a space and put plus 7 at the back. Anytime you see this word,
Yes. That. Dan.
this word is almost always going to be preceded by more or less. So if I say more than, that means, like if it says 3 more than, plus 3. If it says 5 less than, minus 5. Whenever you see this word, then put your stuff at the end. I don't know if you wrote that down or not, but that's going to be something we talk about a lot. More than means plus something. Less than means minus something. But again, head over here and look again. You'll see I very purposely put a space before the 7 more than. It should just feel to you that you've been speaking and reading and understanding English for a long time. And when I say like, my age is 52, someone is 5 years more than me. You take my age plus 5, right? It just feels like the right sensible way to do it. So the word then is go to the back. And now my last chunk, I'm going to put it in another red box for you, is right up here. How do you write twice the first? 2F, done. And poof, presto, you now have an equation. You have an equation that states that the second number is exactly 7 more than twice the first. And now we need to go again. We need to write another equation. This other one should be, I think, pretty simple by this point, having seen it just in the last problem. How are we going to tackle the sum of the numbers is 196? Nope.
S plus 5.
The sum of the numbers is 196. Sum of the numbers just means add them together, right? And it has been a minute since we've seen this, but what method
Times the bottom, like
what method calls to you?
elimination.
Substitution. And you're going to start to see this more and more and more, because now when you go back in time, you say, oh, that's right. The first step when doing substitution is to get a variable by itself. And look at our awesome first equation. It's ready for substitution. So let's just use it. Box method. If you like elimination to the point where you'd be willing to always use it, move things around, that is fine with me as well. Okay. But you're going to see me using a lot of substitution here today. Be prepared to see a lot of substitution. So, but again, if you like elimination to the point where you're willing to take these and always make them look, move the F to the other side or whatever, that's fine, really. But I'm gonna use what comes quickest. So I'm gonna take the red box and I'm gonna put it down here in place of S. Now follow along. My bottom equation is now going to say blank plus F equals 196, right? And what's going in that blank? Yeah. And those parentheses turns out have absolutely no purpose in this problem. I just like to put them to remind you guys that, hey, here's a space where some stuff is going to go. Next up, the 3 sweet words, combine like terms.
3F.
you get 3F. And you know, while we're here, why don't we just save a hot minute? Let's just subtract the 7 from both sides too. Let's just get her done. 2 steps at once. Correctamundo. Perfecto. Good job. And then we divide both sides by 3. And you may think I can't do that in my head. And the answer is, yeah, you can. Just break the 189 into 2 parts. Break it into 180 and 9, and then just divide them both by 3. You can do this. It's 60 for that part and 3 for that part. So we just get F equals 63. Our brains are pretty powerful things. And now all that's left to do is find the other one. And this is where, you know, the box is really my favorite. But in a situation like this, I feel like I could just use some pretty low-level common sense. This, bless you, this equation in the green box is pretty sweet too. It just says, oi, the numbers add up to make 196. So I don't really care what road you go down. If you put the 63 back in the box, if you just use common sense, bottom line is the other number is going to be 133. I think. Did I just mess that up? No, I think I'm good.
This is cool.
Which part of what's this?
Last week we did something that involves elimination. And then this one is involving more of substitution.
What we are doing is we're solving word problems.
Did that last week.
We're going to be solving word problems today, tomorrow, Wednesday, Thursday, next Monday, next Tuesday, next Wednesday. Okay? And I want to stress something I said earlier. It is all about step 2. You're going to find yourself waffling back and forth. Some problems you use elimination, some you use substitution. Solving word problems isn't about the math. It's about, can I take the English words and make math equations out of them? So we are solving word problems. The math that we do, sometimes it'll fit one method better than the other.
So last week we did that substitution for everybody.
We could have, but it would have been absolutely nightmarish. And if you want, I can show you that, but not right this second. I will show you what I mean. But when there are numbers in front of all of the letters, using substitution is just you're just asking for trouble, okay? So now it's time to answer the question. And the question, again, is relatively generic. It just simply says, what are the numbers? And so just keep my sentence nice and short. The numbers are 63 and 133. Done. Okay. Step 1, we declared. Step 2, we wrote a system. Step 3, we did substitution because it worked nice. And then step 4, we answered the question. Problem number 3. Take a moment, read it. What do you think we should call these guys?
MS.
That's what I would totally do. Again, it's already decided that they're called larger and smaller. So I appreciate that, hearing you say that. So let's let L equal the larger number. And let's let S equal the smaller number. Good. The equations will now start to get more difficult. I'm not saying like, ooh, be scared. I'm just warning you that they start to be a little bit harder to turn from words into math. So chunk reading is what's going to be probably what saves the day for most of us, for some of us. So I'm going to chunk it for you. And I want you just to turn the part that I'm putting in a box into math. What's that going to say? It really can't be the bigger number. Like what I'm asking you when I ask you this is I want letters like math symbols. I don't want any more words. I want you just to replace, and you're not allowed to answer that anymore because I need everyone else on board now, okay? You're on fire. Yes, if the number 9 should not even come out of our mouth, we should just have the larger number is L equals. Done. And now we're going to take the next chunk, which is right here, the green chunk. I so badly wish it was 9 minus, but remember, whenever you see this word, greater than, less than, more than, where do we put it? At the back. So if it says 9 less than, it looks like this. 9 minus is not the same as -9. So I really need you to hold yourself really like sternly accountable for that. Okay. With more than, you'll get away with it, but it's just a lazy habit. So again, more than, greater than, less than, that THAN word, stick it at the back. And then in that void that I've created, I just need to fill in twice the smaller. What does that look like? 2s, because it's twice the smaller. Okay. On to the second equation. And the second equation means I better read the second sentence. So here it goes. The larger number is increased by. Stop there, right there. What does that mean?
The bigger number.
And please don't use words. I need math symbols that can go in an equation. L plus, thank you. This is what it looks like. The larger number is increased by. Perfect. And it is not being increased by 3, but very good. It is increased by 3 times the smaller, and we got a name for that. 3 times the smaller is 3s. And then the sentence goes on to say that the result is, I think that means equals 211. And for now, the second straight time, I ask you what method is calling to you. The one we just did, the substitution, the box method, if you will, because the first step of that is already done for us. If I was going to use elimination, it's not a big deal. I would just have to move some stuff around. I'd rather not. It's already got L by itself, so I'm going to box it up. And where am I going to put it? Where the L is, but in the other equation.
Parenthesis 2s minus 9 times 2 plus 3s equals 211.
So this is what it looks like before I substitute in. This is what it looks like in its kind of weighting form. And then we put the contents of the box in here. And as almost always will be the case, the next step is going to be to look for and put together like terms. And I see some like terms. And again, these aren't necessary parentheses. I like having them there, but in the end, I realized I probably didn't need them. But that's okay. It's good to have them just to be safe. So what is 2 s's plus 3 s's? So I'm going to kind of write off my paper. I'm going to head over here in yellow, and I'm going to say 5 s's. And hey, while we're here, let's just add 9 across. Just get her done. What's 211 plus 9? 220. So we're adding 9 to both sides.
Let's add -9.
We're adding positive 9 to both sides.
Oh, wait, yeah, because you have okay.
We divide 5.
And again, you can divide 220 by 5, and you can do it in your head. And you really should, at this stage in your life, be doing stuff like this in your head. Break up 220 into 220. Just let your brain do it for you. Divide them each by 5. What do you get?
40.
You get 44.
Oh, yeah.
So we now know that the smaller number is 44. And again, to find the larger number, I personally would just use the box. So I'm going to take the number 44 right here, and I'm going to plug it into that box right there. And then you math. And when you put that into the box, when you put 44 in place of S, what's 2 times 44 right here? 88. And what's 88 minus 9? Okay, so now we need to gather up all the pieces, make sure we have all of our thoughts together, and let's clean up the mess. When this problem started, someone asked us, what are the numbers? And again, I've got them. They're both here. In fact, at this point, I shouldn't be doing this, but I'm just going to erase everything except the 2 numbers. Got it? There they are. We found one of them earlier. We plugged it in. We found the other one, and now it's time to just clean Write a clean sentence. And again, this is a simple sentence. The numbers are 44 and 79. Done. If you read the next question, you'll see right at the end that there's a little bit of hijinks going on there, right? Some shenanigans at the end. So let's get this last one done. What do you think would be good variables for us to use here? I agree with you. Good job. Way to get that out of there. So I think personally that we should let M equal the cost of a Moogle. These are fake things. I do this all the time when I write word problems. Just FYI. Okay. And let's go ahead and let B, and you can use lowercase or uppercase. I'm going to use uppercase just to be safe. So I'm going to let B equal the cost of a Moogle. And now it's time. I need equations. And so the first equation is actually pretty simple. And it looks like a really long sentence here. Oh my goodness gracious. But what really simply put is that sentence trying to say?
Equal.
Yeah, it's the sum of two numbers is. It just says if I take a Moogle and I buy it, and then a Boogle and I buy one of those, I'm going to pay $18.25. That's a lot of word problem to be able to destroy into such a compact area. The second sentence, I don't think you're going to have any harder time. The people that will struggle the most with word problems are the people that are like, they feel like entitled, like I want someone to walk me through every problem. If you can read, you're going to be okay, but you have to be deliberate with your reading. Let's start with just this much. I'm going to underline it in red. A Moogle costs. That's it. Nothing else. Just that. Yes. Did you say that? Was that you? Nice job. A Moogle costs. Oh, yeah.
Wait.
Cost is like equals, right? And now I'm going to go on and I'm going to read the green chunk. And I'm going to leave a space before I put my minus 3.75. Because that's what 375 less than looks like. And then this last part says the cost of 3 Boogles. So we know what to put right in this blank. 3B is money.
But why do you have two extra numbers? Wait. Oh, wait, never mind.
Are you okay?
Yeah.
Are you sure?
Mhm.
Okay. Word problems are really, really hard until they're not. And when they become more of the not side is when you really embrace reading in chunks. Read a little bit, write a little bit, read a little bit, write a little bit. Keep doing that. And eventually the sentences just pop out. For the third straight time, as advertised, substitution. Okay. I'm not going to use elimination when it doesn't make sense to. It's not what I want to teach you. I want to teach you use the right tool for the job. And I feel like, the second equation is already ready for substitution. And so I'm just going to take this right now, box it up, and let's roll. Where are we going to put that?
In place of M in the second equation.
The B.
In place of M in the top equation, because it is what M equals after all. So my top equation is going to say M plus B equals 18.25. And we can do this whole problem without a calculator. I know it's the first time we've seen decimals, I think. Okay. Our brains are amazing tools. So first I'm going to do the mechanical part. I'm going to put the 3B minus 375 in my very unnecessary parentheses. I'm going to go ahead and get rid of those. Parentheses are needed if you have like a multiplier in front or like a negative or something, but these ones, I don't need them. How many B's are we going to get? Now, at this point, I just want to show you, I want you to feel proud of yourself. You do not need a calculator. If you add $3.75 to both sides, add them in pieces. What's 18 plus 3? 21. And then add the spare change. What's 25 cents plus 75 cents? That's a whole buck, right? So we have, well, $22. And again, we talk as humans, we talk to ourselves a lot about how hard numbers are. And some of us say things like, I suck at this. And I say, but no, your brain can do this. When I ask you to divide 22 by 4, you can do this. Take the number 22 and divide it in your brain into 20 and 2. What's 20 divided by 4? 5 whole bucks. What's 2 divided by 4? It's not 2. It's impossible. It's a half.
Oh, so
Or as I wrote it earlier today in a different lesson, I can think of it as a half a dollar or 50 cents, right?
35.50.
I see people say, well, God, that takes too long. And it's like, yeah, it does when you got a long-winded blabbermouth like me talking you through it. But in the future, if you do 22 divided by 4, you can do it quickly in your head by breaking it up into pieces. We now know that B equals 5.5. Which translation, that means that a Boogle costs $5.50. How are we going to find the cost of a Moogle? Plug it back in the box. That's what the box is for. Or plug it in the equation that you like if you don't like the box. Like this first equation is actually pretty friendly, right? You would agree if I go into this green box, that's pretty nice. One of each, if I buy one of each, I pay $18.25. And if one of them, the Boogle, costs $5.50, this one really just says that a Moogle plus $5.50 is equal to 18 and a quarter. And again, I assure you, we don't need a calculator. If you had $18.25 and you took away $5.50, how much do you have left?
Is it 12?
You have $12.75 left. And that's, how did I add them?
Why'd you add the 25 and the 50? But 25 minus 50 is not 25. It's 25.
I know. So if you that may not be the best method for all of you. So maybe for some of you guys, what you should do is take the 5.5 and put it back in the red box. But here's what I can tell you for sure. And I'm going to just go to some random place. Trust me on this one, please. You ready? If you have $8.50 and you spend $3.75, how much would you have left? It's easy to say $5.25. But here's the deal. If you add $5 to this, you've already gone over $8.50. So you know you don't have $5 left. Are we clear? So the answer couldn't be 5 anything. So let's add $4 to this. And you get $7.75, right? Now, how much would you have to add to $7.75 to turn it into $8.50? And that's why the answer is $4.75. I mean, to this problem. But as it pertains to the other problem, I hope you would be willing to look back now and see where the number in the green box came from. Fantastic. So now we have to answer the question. And the question is, how much would it cost if we were to buy 4 of these and 6 of these? And so I'm going to erase a whole lot of stuff from my board right now. In fact, I'm going to erase everything except the 2 things that I care about. Now, this math problem says that we're supposed to buy 4 Moogles and 6 Boogles, right?
So when you have to multiply?
Definitely. So I have to take 4 times the cost of a Moogle. And I have to add to that 6 times the cost of a Boogle. And again, you might not believe me, but you're capable of doing this in your head. Do I expect everybody to? Of course not. No way. But it's sometimes fun just to flex a little bit and show everybody that, hey, I can do this. What's 4 times $12? 48. But then you also have to multiply 4 times 75 cents. Can you imagine if you had 75 cents and then you multiplied it by 4? You may not know this, fancy fun fact, but it equals 3. 4 sets of 75 cents comes out to 3 perfect dollars, FYI. So this first half is $51. And on the second half, again, just use distribution. What's 6 times $5? $30. What's 6 times a half a dollar? And what's 30 plus 3? Add those together.
84.
Done. That's like step 3 kind of done, step 3.5. Step 4 now is get around and answer the darn question and do it using English, right? No one asked about B's and M's and all this stuff we've been doing. It's time to get with the program and answer the question. So we're going to say something nice and clean, like 4 Moogles and 6 Boogles would cost $84. Capitalization at the beginning, period at the end. Again, I don't see any need for a comma there because there's really no logical pause at any point in that sentence, right? Comes out nice and clean. I'm going to give you the next assignment. I'd like you to work on maybe like 4 minutes worth of it, okay? There will be work time tomorrow, though, don't fear. So we are doing, I would write something at the top of my paper like worksheet 166. As we do worksheets like this, it's good to number them by the page number. That's what's going to kind of help us match things because so I can't imagine that you would think that there'd be enough room to do this on the worksheet itself. So let's get to it. So problem number 1, and I don't intend necessarily that we have to finish this problem, but just kind of to model for you how this is supposed to look. So you got a nice clean sheet of notebook paper. And in problem 1, we're going to first declare our variables. And this kind of goes with the first problem we did today. I think a good logical sort of start would be to say, let's let L equal the larger number. And let's let S equal a smaller number. And don't worry, I have eyes on the clock. I'm going to cut us off here really, really soon. So let's get this rolling. And that way there we'll be ready to hit the ground running when tomorrow comes. Let's see if we can real quick power speed through write our system of 2 equations. What is our first equation going to say for number 1 on page 166? Good for you. So our first equation is the old classic, the sum of 2 numbers is. So L plus S equals 90. Thank you for saying that. How about the second equation?
L minus S equals 18.
Larger number minus smaller number equals 18. Because we're told so, it's quite literally there in problem 1, right? Okay.
And the S's would cancel out.
They would. And I do not want to make you late, so I felt like this would be an okay place for us, if you'd like to just pause here. And again, I will give you some more time tomorrow to hammer away at these, okay? If you wanted to knock a couple of them out tonight because you like that kind of thing, sweet.
So will tomorrow just be a work day then?
Primarily, yes.
Huh?
Primarily.